Okay, that means the presentation is on really devoted to, we will come back a little to the technology behind recycling, but is really to discuss the safety. That means, as has been presented by all the Christians, yes, that means this idea, that means of to remove the right of all single-use plastics. That's something that is really clear in the law. That's part of the Green Pact, the Green Deal. And the idea is to remove all, that is almost all the waste. That's really the idea. And at the end, the intent, that was one of the questions, is not to have waste at all. That means the ultimate goal is not to get recycled plastics. It's not to get any waste at all. But there is something intermediate. That means since we cannot change completely the practice from today, the intermediate step is recycling. That's what you have to imagine. But at the end is to have no waste. Oh, please, that's also that you have to imagine it's really a massive pressure from the politics. I just show you that there is a text that has been voted by the European Commission in 2019 that states clearly, that means, if I read, that means we reiterate the objective to make all packaging reusable and recyclable economically in 2030, and we call the Commission to propose and to present a legislative proposal without delay. That's what the representative voted. That means because they don't want anymore to have landfill incineration, that we need to at least to reorient rapidly all the waste through the recycling process. And the intent is to reduce, that is, there are two tools that will be used to reduce domestic waste and to put back the waste you produce at the entrance of the chain of value to propose new packaging. And due to the short shelf life of food, that means 50% of the plastics are coming from the food packaging itself. That really is why food packaging is really a main concern. Something, because now we have not only, that means decision has not been only taken by the European Commission, but something that has been voted by the European Parliament. That means in April this year, April 24, it's the new packaging waste regulation. That was a directive before. That was a directive of 1994, but many people and many observers of OCDE noticed that between 2000 and 2019, instead of reducing the amount of waste, they doubled. That means that's the law before did nothing. And there was even the contrary, that there was an acceleration of the amount of plastics which are used. And something we don't understand well is that means we are eating almost the same. But Christian, you said yesterday that we are eating a little bit more, but I couldn't explain why we doubled the amount of plastics. And we think seriously when we develop the platform fitness that we have to address and to tackle that. Why? That means professional encouraged to use more packaging since we don't, for the same kind of food. That means we have to revise a little the way we use packaging and for sure plastics. That means if you read the law by 2025, that means next year in December, 50% of plastic should be recycled. That's next year. That is tomorrow. If you read it carefully, the law is clear. That means this target is not for food packaging. We have a little more delay. That means is by 2030, and for one type of plastics, PET, 30% of the content should be recycled at least in 2030. That means in 5 years. And the point that you have to notice is that initially the law say all plastics need to be recycled, and in the feed of food, they just mention one plastics. That the one which is available currently on the market, which is PET, one polyester. In France, we have a law which is a little more coercitive, I would have said punitive. That means they say that all plastics, including for food, should be recycled by January 1st next year. That's something which is not applicable because we don't have this kind of recycling materials. But it means there is a strong, very strong push. That has been discussed a lot with the PET. I don't want to come back. In particular, what is available today is mechanical recycling. You can turn the problem you want is post-consumer. And when we say post-consumer, that means most of the plastics should be with an origin. That means from households, and mainly that means this plastic should be in contact with food. That means that's 95% of the input for now. That means that they sort, they recycled. That means you sort, you green, you wash. Then you have a recycling technology with the degassing. You can use solvents also. Then you get pellets, you can get sheets, flakes. Then you process again, you convert them into new materials. That's really the basic principle. It's really quite simple. It's not really a complicated technology. That means that look quite simple to evaluate. One of the questions, why we cannot do that for other kind of materials? And the key point, that means I asked ChatGPT to help us a little to represent what is really the problem. We want to protect environment. That means we don't want to put this kind of waste in the environment, is why we want to collect them and to recycle them. Then the question is it safe to use the packaging that is a waste? Imagine you are at the beach, is it safe to drink from any kind of these plastics? And I choose a shape that are not really food contact. You have a shampoo bottle, so you have a soap, you have detergent. That's really one of the aspects that we have to consider, because with the linear economy, that means we could build everything with something pure, virgin. That means it's pure, then we can build safety from purity. If now we enforce the circular economy, that means we need to use a waste. And take at the picture on the left, I think it's quite clear, you see a food bottle. But the shadow is not showing you a food bottle, because in the past, in the previous life, this packaging was something else. And the question is it safe? Can we manage that correctly? The problem may look simple. You can say we just need to manage it with a piece of paper. Okay, then the questions, you have a big ship with a lot of recycled materials that arrive within the EU at one of our entry ports in Europe. Do we accept it or not? Is one single paper enough when you will receive, can feed or can satisfy 1/3 of all the needs of Europe for these materials? It's complicated because that can be highly viable. That means the key is that if we shift, and we are shifting from linear economy to the circular economy, we cannot avoid hazards. Sometimes you will have very hazardous, harmful substances inside. We are sure that. The question is the risk acceptable? One key issue is to say that even if these bottles are contaminated, if we take just a case of bottles, because you put herbicide, you put oil, you put anything that is harmful in the bottle, at least that will be mixed with the others. The mixing will prevent it to have a too high concentration, even if in some cases that may happen. What will happen when we will generalize that? That means everything is in the measurement of the risk. The risk never, or the hazards, just to have, if you drive along the road with your car, you will see signs. Signs represent, some signs represent hazards. Risk is the frequency of occurrence of one of these hazards. That means if you see a sign that you can receive, or you can eat animals, or you can receive rocks on your car, that's the hazards. And what is the risk you will meet one of these hazards? In the case of eating animals, when I asked my student, they told me 20%, 15-20%, even if they are young, they have eaten one animal in their life. That's this kind of information we need. Then if we take a look at the fact, And I want to choose, it's not necessarily on purpose, but that's really the main interest. We should not target only polyesters and PET. PET is quite simple because PET is quite pure initially. You don't build buildings with polyethylene phthalate. PET, you don't have PET in your car. But if you take polyolefins, polyolefins is a ubiquitous materials that is used for many, many purposes, and which is much more formulated. And we need it also for packaging. It's 1/3 of all food packaging applications. I take the case of polypropylene, which is really resistant semicrystalline polymer. You can eat it, it won't melt. You can put it in a microwave oven. You can subject it to hot filling. Sterilization is really in the field of food is really important. If it is a virgin, it's GC chromatography, that means bidimensional chromatography. That means one dot is one substance. And if you take a recycled PP, but you have a much more dots. You multiply almost by tenfold the number of substances inside. You have much more chemicals inside. That starts to be really highly challenging. And I take, that means the example, that means that's something we did within the consortium Cospatox is devoted to cosmetics. That means during the project, that means we collected 34 samples of recycled materials, polyolefins. And I take one example, is one reference, is a typical example, it's not something too specific. It's identity polyethylene, recycled, is a reference 4. And we imagine if we could use these plastics for a cosmetic application. It's not as strict as food. We don't drink from there. And we imagine 3 possible applications for this material: shampoo, shower gel, and lotion. One thing we need to do is to evaluate the hazards inside the recycling, how many substances there are inside. We identify 54 substances, and there are 94 substances in GCMS. They are not well identified. That means the concentration is low. We know that they are there, but we don't have an exact chemical structure for that. And we have a threshold. If the hazard is genotoxic substances, that means we have a threshold of exposure. That means it is a set within the EU by EFSA. It's 0.0025 microgram per kilogram body weight and per day. That's the acceptable exposure for genotoxic substance. And it's known as genotoxic TTC for people that know that. That means in this case, we have one substance that exceeds, for shampoo, adult, that exceeded this exposure. By chance, we know the substance because it's green, that means it is identified, and this substance is not genotoxic. If we take now the example of shower gel, it's for a child. In this case, we have 45 unknown substances, that exceed the genotoxic threshold. It's super challenging. They exceed the threshold. That means it's not okay for a shower gel. Then that means the last, it's a body lotion. That means something much more oily. And in this case, we have 135 substances that exceed this threshold. We see clearly that we could use these plastics safely for shampoo, not for other applications. Now imagine again, you have the big ship with, that means thousands of tons of materials. You may have a viability inside, and you have to find the right target for this enormous amount of pellets and plastics, and you just have a paper sheet. How you will manage that? Since the law is clear, we need to use it. Something a little complicated, do we need to use something which is imported? According to the law PPWR, everything which is entering now in the EU should be as safe if it is imported, as safe, and also as environmentally friendly. Both conditions need to be verified. That is, it's really complicated. And if you take a look, that's some result from your group of Christian. That means that's the result of Frank Vell. That means I just took the table where Frank made a survey, what we can find in PET that has been in contact with the detergent. I mean, and yes, again, you have a confirmation. In this case, it's not polyolefins. We are in a polyester, something, and in this case, again, we have some structural alerts that say, for some of them, we may consider them as potentially genotoxic. These substances are not fully evaluated. They have different molecular weight, but they can be there with some amounts that are highly variable. And one in this study, that means the question at stake is whether the rule of 3 milligrams per kilo in the stream of polyester was still applicable 20 years later after its definition. That was really what was at stake. And the conclusion of the authors that its white could be okay, but that need to be really controlled. If we take now much broader study, that means what we can find in plastics, because in plastics, the message is quite clear. Even in virgin plastics, we don't find only genotoxic compounds, but also endocrine disruptors. Endocrine disruptors for human, for the environment. Some of them are persistent bioaccumulative. That means we find a lot of things, not just one single class of hazards. And again, now, if you use a recycled material, that means they are not safe for all use. And perhaps for some food, we should reduce the shelf life. If it is it's just water in a bottle, it's quite easy. A soda, why not? If you take that means a Coca-Cola, a Pepsi-Cola, that means don't worry, it's not really difficult. You can fill the bottle at room temperature. Nothing can survive inside. If you fill this PET bottle with an orange juice, first, the material is thicker. You will fill the bottle at much higher temperature. It's subjected to hot filling, typically 72 degrees Celsius. That means the risk of mouth sulfur is much higher. It's still an aqueous product, but now imagine you put inside something much more oily. It's an emulsion. It's a yogurt. That can be more complicated and really much more challenging. In some cases, because the modules is not as safe, we can make it safer by adding a functional barrier. You will have a presentation on it. Some recycled plastics are not as safe for kids. They cannot be rated in the microwave oven. You cannot do that. We discourage repeated use. By law in France, next year, we need to indicate on the labels whether we have endocrine disruptors or not. We will claim that some food are not acceptable, are not convenient, and they are not safe for pregnant women, for example. And also we have to enforce the border control. Many questions. And what I try to share with you is the origin of the risk. What do we know today from the origin of the risk? Please, first, the waste and the way they are collected, they are mixed. Something you have to imagine is really a strong mixing of everything. And even if you have a different kind of being at home, you don't separate food waste from others. Food waste, that means food packaging waste from cosmetic packaging waste and other things. They are not separated at all. They are sorted by the industry. That means it's quite easy to recognize that means a water bottle. It's more difficult to recognize other kind of themes. That means trays. Other packaging may be difficult to recognize. Something that we need to prevent, in particular, if we use a mechanical recycling, which is one of the very few viable solutions for now, is upcycling. That means is to prevent to have this gasoline container recycled in a bottle. We need to prevent that. We need to prevent also, for efficiency, what is the downcycling. For example, the cosmetic industry like a lot. That means water bottles. Yes, but they cannot absorb all the bottles that are used or produced by the food industry. That means that's not really the solution. And this system should not compete. You eat, in Europe, we accepted you eat 1 kilogram of food every day in contact with the kind of packaging that you test. That's the European rule. For cosmetics, in the worst case, we assume that just 18 grams of products remain on your skin. It's not 1 kilogram of products. That means, with a simple rule, that means plastics in contact with cosmetic products could be 55 times more contaminated, is 1000 divided 18. They could be 55 times more contaminated than food packaging for the same kind of risk, for the same kind of exposure. Also imagine that, okay, we have the risk of exposure for food, we have the risk of exposure for cosmetics and for many things. That means we start to accumulate a lot of risk. Also imagine we accumulate also many chemicals. As I show you from the Cosmatic project, we have to consider that 10% of the chemicals inside a recycled polyolefin can be potentially genotoxic. That means we are not exposed to one single substance, but to many. If we accept a risk of one cancer for one substance, one cancer every 1 million, if you have 10 substances, that means now the rate is one cancer every 100,000. Do we accept that or not? When you ask EFSA, they are clear. That's political decision. Or that was just for cancers. But now you will find the literature that we are also, that means the Food Packaging Forum is also collaborating to the project Fitness, and that review they did, and the point of view is not just to consider just one endpoint, that means genotoxic or carcinogenic substances, but one not to consider cardiovascular diseases, reproductive, brain-related disorders, immunological disorders, metabolic disease, and if you include a more endpoint, you will see more effect. That's quite obvious. And you can have a really cumulative effect in this case, and we know really little about that. Something I share with you, it's a result, this from the group of Wagner in Norway. And they identified, that means they screen, if I remember, it's 20 plastics. So they screen different 20 plastics with a specific methodology that enabled us to look at simultaneously at 6 endpoints, and they could separate the different chemicals. But just to make it short, that identify, that means in commercial plastics today, a lot of chemical features that justify, that means the awareness. These plastics, perhaps one was recycled, not the others. They did not discuss this a lot. They compare with different materials, but they say that will be highly challenging. Or just for your information, that means if you take polyolefins, they are virgin, and this one, you have a much more features. If we start to recycle even polyolefins, we will have more. PP, not bad. Or they are not happy with polyurethane, PVC, and some composite. Just to show you that will be challenging in the future. And the question is the evaluation. Oh, please, that means I play a little with the ChatGPT, I exaggerated a little. That means it's not like that necessarily a plant, but you see really the problem of sorting. I ask for a lot of colors. That is really, if you increase the amount of recycling, you have to imagine, and the way of the rate of collection, you have to sort all of that. And currently, that means we have different technology because we have to think about today and the future. That means you can recycle, that means polymer directly. That means you just melt them, you mix them, recycling, that means mechanical recycling, at least you don't do chemistry, it's just mechanics. You just melt them and you mix them with other polymer chain. And you try to dissolve molecules at above the melting point at high temperature. In particular, for PET that works well, we are really high temperature because the melting point is typically it's above 260 degrees Celsius. If you want to melt it, really, many substances are volatile. If you take polyolefins, don't melt them at so high temperature, that will be difficult to remove also less volatile compounds. And they are much more because it's a rubber material. That means the solution could be to have either a partial depolymerization to get to some blocks, or to go back directly to the monomers. That is, to go back, that depends on the kind of polymers you have, something volatile or not. All of that is really available. We make rapidly a review because there are many things available today. You have what we call mechanical recycling, something with dissolution. In this case, with dissolution, you can wash the polymer. If you have semi-volatile compounds, perhaps they can be removed because they lack the solvent. So for some polymers, in particular for polyolefins, the only solution is to go to pyrolysis or to other kind of, or hydrolysis, that means for polyester, and to make again polymer. You will see you will have, that means you will have really a review. That means mechanical recycling is just mixing. That has been presented, and you will have other illustrations. This one has been published 2 years ago in Green Chemistry. And I don't go back to that, but the point that we have, is it safe? That's a sketch I did. You see, it's quite simple. You put almost everything at the entrance, and at the end, is it safe to drink? Something I share with you, we did a really basic experiment. That's something that we did in the group. We still have to publish that, but it's quite extensive, the study we did. We put 2 plastics. That means that in this case, they are polyolefins, and it's LDPE, EVA. That means we put this substance, which is, you can see it because it has a color, it's pink, and is a fluorescent. Initially, that means the substance is put in the top film. You have a bottom film that has nothing, and you have 1 centimeter of a liquid. That could be pure water, that could be ethanol 10%, ethanol 30%. And we put them in contact for 2 hours. And the temperature, that means, is 40 degrees Celsius. That is not an enormous temperature. When you wash PET, you wash PET at 90 degrees Celsius, even above the glass transition temperature of PET, and the glass transition of PET lower a lot in water that can be as low as 60 degrees Celsius, even below, for people that know PET. It's not basic level, what I'm saying. Please, for those that have difficulty to follow, is attend other lectures that we put in fitness on polymer if you have difficulty. But the point is, if you just have a water between 2 films in 2 hours, you can transfer 2% of the chemicals from the top to the bottom. If it was something with a surfactant or little ethanol inside, half of the substances can be transferred. That means when you put a waste together with a little liquid film, these substances is super hydrophobic. It doesn't like water. That's not a problem. But since you have the 3 phases, not 2, you have 1 plastics, 1 source, 1 liquid, and a reception phase. And in time, the concentration in the liquid is almost 0. It's really difficult to see, but it does not prevent necessarily mass transfer. The way the processes are evaluated, that means, and what is asked is to have 2 things. Currently, based on SR rules and also what the FDA is enforcing, first, you need to evaluate the process of decontamination. You need to get a value of the decontamination rate. It's relative. You have 1 amount, you need to demonstrate that you lower this amount, for example, by 100 times. That is decontamination rate of 99%. That depends on the molecular weight. That means you cannot decontaminate with the same rate any kind of substance. Since you use the devolatilization, small molecules are easily removed, larger are much more difficult to be removed. Is why, that means in the process, we ask you to validate that at the end, the exposure you reach in food is acceptable for all the substances that you may contain in your stream or in your material and in your finished article. It's not enough to say I decontaminate with 99%. You need to demonstrate that the exposure for infants, toddlers, babies are acceptable. And for any kind of substance, where we consider that the substance is genotoxic. And I tend to confirm you that we have to consider it. At least for now, according to current practice, they ask you uniquely to verify if you have genuine toxic compounds. But that's really strict. That means you need to use modeling, because at the end, the maximum concentration could be acceptable in the food for genotoxic substances is so low that it cannot be measured. For an adult, you reach 0.15 microgram per kilogram of food is below the detection limit that you can reach on standard. The only way to do that is to use modeling. But we have the solution: fitness, proposed lectures, or modeling, simulation, risk assessments. That means is why please use the platform as much as you can, because we explain a lot of things. Or what could be the future? One future could be for sure the closed loop, to be sure that a water bottle is becoming only a water bottle. That could be one solution. Something else, for sure, the chemistry could help. If we could recycle chemically, that is by breaking polymers, we could make quite pure polymer again, whatever the sourcing. It's energetically is not always super efficient. Environmentally, not always super efficient. But please, the technology are developing. You have big investment in the EU in particular. I share with you some of the directions that are taken. For the recycling of PET, you have many solutions that has been proposed. One of the solutions, one of the big plants that is built currently in France is methanolysis. That means one of the solutions. Please, again, if you use this kind of technology, you change the nature, or you may have different kind of monomers, not one single kind of monomer. The chemical signature may change. Something I share with you, because that's something that has been done in collaboration with my institute, that means is to use enzymatic recycling of PET. They published this in Nature in 2020. Quite famous, that works quite well. That means in 2 hours, they need 2 hours even, at a really intermediate temperature, but they can hydrolysis. They get 99% of hydrolysis of polymers. And the publication on the right is from a Chinese group. That French one on the left, that is a Chinese group that try to repeat and to improve that. The key, because there is a really strong technological development, they screen more than 1 million of hydrolase. That means they screen more than 1 million of enzymes to be capable to find an enzymes that can work at more than 80 degrees. That means can resist a very high temperature and work in these conditions. For polyolefins, if we want to use, and perhaps that will be in the future the only viable solution for contact to bring back. That means cosmetics. Someone is waiting. Okay, that means, and pyrolysis could be one of the only solution. Complicated, not so easy. You have different kind of reactors that can be proposed. For those that like chemical engineering, please invest in chemical engineering, because they need help for pyrolysis. That could be one of the solutions. Now I go back to some takeaways. Okay, that means just some takeaways. Please, if you have a question, put them in the chat. We are not fully necessarily in advance. That means the point is that we need to do. The point is that, as I say, it's difficult to evaluate. That means the sourcing and to find the right application of the feedstock that you have, because normally we need to optimize. If you have a feedstock a little contaminated, you don't want to have it for babies, for example. Okay. By the way, that means you are there. I will discuss for you. That means that one of the difficulty is that we need to optimize the feedstock for the right food application. That's one of the elements of the difficulty. there is a small risk of downcycling. That means if we have something pure, a very pure plastics that we use for something that is not where it is not necessary. There is a risk that we use something impure for something in particular for hot filling, for babies, for. I was saying that means it's difficult to adapt the feedstock to the food application. But once you design your food packaging, you have to imagine that this food packaging will be recycled again. And we need, and perhaps there's something virtuous to make is to say, if I have something which is acceptable for this application, why should I mix it with other kind of feedstocks? Perhaps we have to preserve some qualities as much as we can. That will be difficult, but if we can recognize, that means when they are sorting, perhaps they can recognize some kind of packaging to be sure that are reused for the same kind of application. It's a dream that works really well for water bottles and soda. That should be generalized in the future. There could be one solution, and we expect that we need to find new ideas, new innovations. Something also which is difficult in connection with the content of the platform is that we have to take for people that deal with food packaging, they don't deal only with the recycling. They deal with all the problems at the same time. And they need to take a lot of linking decision. They need to design their food packaging to have something that is okay for the food, that means to get the right shelf life. They need to find the right food grade. I insist a lot about processing, because they need to find the materials that can go to the processing line. If you replace a multi-layer by a single materials, you won't have the same thermal stability, the same mechanical stability, and you need, at the same time you change the material, you need to change the machines, the machinery around, the processes, perhaps the conditions, and perhaps you have to revise the shelf life of your food. It's complicated. I say we have to imagine that the packaging itself is a waste, and we have to imagine a future for this waste. That's also complicated. And we have to think about other alternatives and practices. Is it safe to recycle? Is it safe to reuse? And one day we will ask the question, can we have recycled packaging reusable? That means, because perhaps we can reduce, if we have a packaging, why immediately after consumption we need to put it in the trash? Perhaps we can find another route for this kind of packaging. Please, everything is open, but we have to consider all of that. What I put around, that's illustration of lectures that are available. That means some constraints related to palatability, that means of the storage of food, others about thermal processing, because it's really important, because we have other risks to manage, and not only the chemical risk, the microbiological risk is really important. Things we did with the group Pernod Ricard, and that's part of which is public, is how there is eco-design of packaging. That means packaging filling. That means please go to the platform. You will find a lot of content. Something that I put in several of my communications, sorry, we are losing connection, is to think big about engineering. I like that. That means when we start with from chemicals is what we call assessment. And something that we have to do is also to think about the reverse process. At the same time, please, we have to be imaginative. Please, for students attending or young professional, please learn engineering. That's good for the future. Don't buy just things because it's written that you have to use it this way. Be confident with nothing. Please train yourself as engineers. If you are more curious, please train yourself as a scientist. We can welcome you. We represent different laboratories. Please, that's also the future. We don't have the solution today. We don't have everything. But we maintain one thing. If we think all together, we collectively, we can find solution. And we can put some objectivity. Safety require objectivity. We need facts. That's all, and everything is related to a choice of the society. For some of you, you saw it already. I like it. What is creating the risk is first ignorance. And welcome, that means fitness is fighting first against ignorance. Thank you a lot.